All right. Before we actually get into these notes, I want to explore what is actually happening here. So this unit is on triangle congruence. Literally, it's just understanding and knowing when two triangles are congruent to one another. Now, what does congruent mean? Not just equal, which equal means same size, right. Equal means same size. Congruent is same size and same shape. Both of those things need to happen for two things to be congruent. So let's look at these two triangles here. I'm going to mark some parts congruent with hash or tick marks. And what are these things called in the angles? What are those called? Arc marks. Arc marks. I heard someone say arc marks. They're arc marks. So how many parts is a triangle composed of? How many parts are there? There's more than 3. 6, right? 3 sides and 3 angles. Now, here I clearly have all 6 parts of the first left-hand triangle congruent to all 6 parts on the right-hand triangle, meaning that we know for sure that these two triangles are what to each other? Congruent, right? All of the parts are the exact same size and shape as all of the other parts on the second triangle. Therefore, we know that they're congruent. Now, what if I did this? Do I still know that these two triangles are congruent? Don't tell me. Discuss within your groups. Are these two triangles congruent? And give a mathematical reason why. Thinks that they have a really solid mathematical reason why these two triangles are still congruent. Anybody? Here.
So since all the angles have to add up to 90, and so since the first two angles
Yes, you're right.
180.
Yeah, there you go. They all add up. You're perfect. You're great. We know that 3 angles in a triangle have to add up to what? 180, right? So if I know these first 2 angles are congruent to these first 2 angles, there's only one other measure that the third angle can be. Therefore, we know it's congruent to itself. Or congruent, the left-hand missing angle is congruent to the right missing angle. So yes, we still know they're congruent. Now what if I did this? Are these two triangles still congruent? All right, so do we think these triangles are still congruent? Raise your hand if you think yes. Raise your hand if you think no. Okay, pretty good. Yes, these triangles are still congruent.
Does it look the same?
Not because they look the same, but yes.
Is it the same thing if those two angles add together, then the line has to be the same or make the angle different?
Right, exactly. So say we kept the first triangle the same, right? But then we tried to maybe extend this side on the right-hand triangle, the one that we no longer know is congruent, right? So say we try to make it longer. What would that also change? It would also change this angle. What else would it change? The length of this side. But no, we know that this angle is congruent to this angle. The 1 arc mark is congruent to the arc mark, 1 arc mark. And the 3 tick marks is congruent to the 3 tick marks. So we cannot actually change the size of this missing side or the size of the missing angle. They have to still be congruent. What if I did
Whoa.
Are these two triangles still congruent?
No, because then you can change the bottom, right?
So say I did change the bottom. Say I made it longer. What would that change? It would change this top angle, right? Can I do that? No. Can I make this bottom side shorter? No, because what would that change? It would change the top angle. Is there anything that I could change here and keep these parts congruent that I have? No. So, do they remain congruent? Yes. These are still two congruent triangles. Now, what if I did this? Oh, well, now we have no triangle. What if I did this? Are these two triangles still, do we still know that they're congruent?
Yes.
Think of what you could change that won't affect the one arc mark angle and the two tick marks. What could you change that won't affect those? Yeah, I can for sure change the length of this bottom side. Why can I change the length of that? Right. I don't care what the top angle is, and I don't care what this bottom right-hand angle is. It doesn't affect the one arc mark or the two tick mark. So, are these two triangles still for sure congruent? No. And in fact, that's what today is all about, is knowing what is the least amount of information possible to still prove two triangles are congruent. And the least amount of information possible, these things are called congruence postulates. And there are 5 of them. And that's what we're about to go over. So, go ahead and take out your notes. We have 5 things. These 5 things: SSS, SAS, ASA, and AAS, and HL. These are called our triangle congruence postulates because they prove triangles are congruent. Now, what do you think SSS stands for?
Social security system.
Sure. Yep. In math class, we're going to go over Social Security. Yep. What have I just been have we been talking about? Oh, triangles and triangle sides. So SSS stands for side, side, side. But it's not. It's 3 sides. SSS. Now, the SSS postulate states 3 sides of one triangle are congruent to 3 corresponding sides of another triangle. What do you think corresponding refers to? Yes, very good. Corresponding means that if I was to take one triangle, one congruent triangle, and lay it on top of the other, the corresponding parts would be lined up. So what is corresponding to O? A. What is corresponding to B? What is corresponding to W? What is corresponding to BW? MN. What is corresponding to OW? AN. Beautiful. That's all that corresponding means. It means the parts that relate to the other parts in the second triangle. Okay, so what I'm now going to do is I'm going to mark these 2 triangles are congruent by side, side, side. So I'm going to mark OB congruent to AM, BW congruent to MN, and OW congruent to AN. So now, what I like to tell my students to do once they have their parts that are congruent is I like to say you need to label the parts that are congruent with S's and A's. So tick mark represents a congruent what? Side. So I'm going to put an S for the 1 tick marks. This side is congruent to that side. 2 tick marks now. Side is congruent to side. And then the 3 tick marks. Side congruent to side. Why do we do that? Very good question. Now, how does this left triangle now read? SSS. How does the right triangle now read? So you for sure know that these two triangles are congruent by SSS. I just realized I have not done attendance all day long. So that will happen in a second. It is fun, yeah. All right, next we have SAS. What do you think this stands for? Side, angle, side, yeah. Side, angle, side. Side, angle, side. The side, angle, side postulate states that two sides and an included angle are congruent to two corresponding sides and included angle of another triangle. What do you think I mean by the word included? It is part of the triangle, but specifically, where is the angle in comparison to the sides? Where is the A? The A is between the sides. In math, this is what we call an included angle. It's between the two sides. So, on our picture over here, I'm going to draw a side congruent to a side. Let's do OB congruent to AM. And then another side, BW congruent to MN. Now, if this is congruent by side, angle, side, where do you think the angle goes? Good. On the left triangle, it's which letter? B. It's congruent to what on the right triangle? M. So now, if I'm labeling this with S's and A's, I have S for the tick marks, A for the arc mark, and oh no, it's going to crash. And A's for the arc marks, and S's for the other tick marks. So now, how does this left triangle read? SAS. And how does the right triangle read? Because they are the exact same, these two triangles are congruent by SAS. Any questions so far? Now, we are, of course, marking parts congruent here to show that this is what SAS looks like and this is what SSS looks like. But do you think that when we get to the actual problems, you can just willy-nilly label anything congruent that you want?
No.
No. It has to explicitly tell you. All right, next one is ASA. What do you think that stands for? Angle, side, angle. An angle, side, angle. That postulate states two angles and an included side now are congruent to two corresponding angles and included side of another triangle. So where is the side in comparison to the angles? In between the two angles. It's included between the two angles. So over here, I'm going to mark O congruent to A and W congruent to N. And if I have an included side, where's it going to go? On the left triangle. Which one? Which side? OW congruent to? On the right? AN. Beautiful. So now I mark this with S's and A's. A's for the arc marks. S's for the tick marks. And A's for the arc marks. So how do both of these triangles read? ASA. They are congruent by angle, side, angle. And last of the normal postulates is AAS, which, what does that stand for? Angle, angle, side. Angle, angle, side, the postulate states two angles and the non-included. Meaning it's not between the two angles anymore, it's outside. The non-included side of one triangle are congruent to two corresponding angles and non-included side of another triangle. So I'm going to do AAS now. We'll do, let's see, B congruent to M, W congruent to N. And where does the side need to go to make this AAS? Where's the non-included side going to go? On the left-hand triangle? What side is not between the two angles that I have here? O and W, perfect. Is congruent to what on the right? A and N, perfect. So now I mark this using A's for the arc marks, for the angles, A's for the angles, and S's for the side.
Why is it not BO and
It could be, yeah. So now, how do I read this left-hand triangle? So very good. This is a common mistake. Your eye, because it wants to read in order left to right, you want to read this as ASA. However, that would be incorrect. Just like how you read a sentence and there are spaces in between each word, right? Is there ever two spaces between two words in a sentence?
No.
No. Here, if I go A, S, A, going from A to S, how many parts am I skipping? A side and an angle. You can't skip two parts. You can skip one, so to go from angle to angle, I'm only skipping one side. So if you try to go A, S, A, it's wrong because you're skipping two parts. You're reading it wrong. This is actually A, A, S. Does that make sense? So it's congruent by AAS. All right, last one. HL. Anyone want to take a stab at what HL stands for?
Horizontal line.
Yes. How'd you know that?
Once more. I like it wrong.
Yeah, I'm sorry. Hypotenuse leg. It was, but every single class, someone guesses it. And I'm like, wow, you're smart. No. Oh, it is kind of in the directions a little bit, the explanation. The hypotenuse and leg of one triangle are congruent to the corresponding hypotenuse and leg of another triangle. Now, specifically, what type of triangle has a hypotenuse? It must be a right triangle. Must be a right triangle. So over here, first thing you need to check for is, are these right triangles? Yes, they are. Then you check, okay, is the hypotenuse congruent to the other hypotenuse? Well, we don't know. I mean, these are blank triangles right now. But where is the hypotenuse? A, B, right? the hypotenuse is the side across from the right triangle. I mean right angle, jeepers. The hypotenuse is across from the right angle. So AB is our one hypotenuse. And what's the hypotenuse on the right triangle?
D and E.
Beautiful. Now, what is a leg? In math, what is a leg?
Wait, isn't it the angle with the angles, the side?
So line is not the hypotenuse.
Right. Anything besides the hypotenuse in a right triangle is a leg. So both the horizontal and the vertical sides are termed legs. So as long as one of these is congruent to another, this becomes hypotenuse leg. So I'll pick this leg here. So here we have a hypotenuse congruent to hypotenuse, a leg congruent to a leg, and of course it's a right triangle. Therefore, these are congruent by HL. Now, you should not immediately see a right triangle and say, oh, let me check for HL. What clues you into checking for HL is if, when you're labeling this with A's and S's, what does it become? How do these triangles read? Angle, side. So if I was to put, now don't put this on your paper, but if I put A's and S's, how do these triangles read? ASS. Was ASS one of our congruence postulates?
No.
No. In fact, it's not a congruence postulate, and we'll go over that in a second. When it reads ASS and it has a right angle, then you check for HL, okay? So, now what I want you to do, this won't pause. So now, on the left-hand side, right next to the notes that you just taped in, I want you to write down non-congruence postulates. So basically, these things are not congruence postulates. They do not prove congruence. Don't worry about drawing the triangles yet. Just write down non-congruence postulates. Now, what do you think the non-congruence postulate is? What did we go over that I said does not prove congruence? ASS. Perfect. ASS. Angle, side, side. Now what I want you to do, oh boy. Now what I want you to do is draw two triangles. One that is perfectly solid on all three sides, like this. And then the other who has a dotted bottom side.
Wait, is it supposed to have that weird line?
Yes, it is supposed to have that weird line. And then, yes, a strange line over to the left-hand side on that right-hand triangle. Now, the reason I had you draw these two triangles just like this is to show you. I'm going to mark this left-hand triangle with angle side side. So I'm going to put an arc mark here. And then I'm going to put one tick mark. Oh, you can't see these very well. One tick mark. And then I'm going to put two tick marks. So this triangle alone reads ASS. So now, what would the corresponding angle be to this blue arc mark down here on this right-hand triangle? Where should it go?
Right there.
Bottom left. Perfect. So I'm going to, yes, put that blue arc mark. Then this one tick mark remains the same. However, The reason why we have 2 lines drawn here is because this last line could either be drawn normal, like we had in the first triangle, or it can be swung inward and still be the exact same size.
Do we ever have that?
Yes. So this, it's proving that ASS does not always show congruence, because do we know what this top angle is? No. So therefore, I can take this outside side and swing it inward and keep it the same length, but it changes the top angle, making these triangles no longer congruent. Because we don't really know where this outside 2 tick mark side is, because we don't really know where it's located, this is what is called an ambiguous case. We really don't know where it is, what it is. It's ambiguous. So because this is ambiguous, do these uphold congruence? Do we know that these 2 triangles are congruent? No. Do you see it? Do you know what I'm talking about? So if I erase that, do I have the blue arc mark the same as the blue arc mark? Do I have the 1 tick mark the same as the 1 tick mark? They're the same length. Is the 2 tick mark the same length as the 2 tick mark? It's not the same length?
It is.
It is. But are these triangles congruent?
No.
Look at that one. It's so much smaller. They're not congruent. But it still is ASS. ASS does not guarantee congruence. So that's why these 2 triangles are not congruent. There is not enough info. Not enough info. Okay, who can take a guess at what our next arrangement of sides and angles is that would not show congruence? Angle, no. Angle, angle, angle. What? It is a triangle, but it doesn't mean they're congruent. Now, are all triangles congruent? Nope. Can anyone think of why angle, angle, angle could not be congruent? Yes. Oh my gosh, I love that vocab, because you can dilate it. Look, I have a big triangle. Oh, let me do this. With 60, 60, 60. And then I have a little triangle with 60, 60, 60. Are these 2 triangles congruent? Heck no, one's way smaller, but they're still angle, angle, angle. So even though these two triangles are angle, 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 they are not congruent. Angle, angle, angle does not prove congruence. Go ahead. Not enough info. It's like hot in here too.
Yes.
Maybe I should leave the door open. Thank you. Didn't take the pass. Go ahead, John. Oh my God, Jamar. All right, now there are just 2 more things that I want to talk about. So draw a little line. Remember how earlier I said that you can't willy-nilly mark parts congruent? You can't just say, oh, it looks like the same size, so I'm going to mark it congruent. That's bad math practice? Sure. Okay. There are 2 exceptions to this rule. 2 times that you can mark congruence even though it doesn't tell you. So I like to call this when you can mark extra parts congruent. The first time that you can do this is when you have what is called a reflexive side. A reflexive side, and if you remember, in our guide to proof heaven, the reflexive property is when a value is equal to itself. Something is equal to itself. This is called reflexive. So, you have a reflexive side when you have two triangles that share a common side. So you see how we have a left-hand triangle here that backs right up to a right-hand triangle? The side that they share, that middle line, is called your reflexive side. And you can always mark it congruent to itself. It's always going to be the exact same length, right? The second time that you can mark parts congruent when it doesn't tell you is when you have vertical angles or parallel line angle pairs. I'm not really going to go over parallel line angle pairs. Do we remember those? Like if I had, you don't have to draw this, but if I had triangles like this and then I said the top line is parallel to the bottom line, alternate interior angles are congruent, and I can mark them congruent. Vertical angles, however, normally they'll draw something like this. What can I mark congruent here? Where? Yes. The two intersecting lines form two what? Vertical angles, and I can mark the vertical angles are congruent. These are the only technically 3 times that you can mark parts congruent when it doesn't tell you. Any questions at all?